Okie doke. Sleep is good. It's the weekend. I'm all set. I'm not tired. I'm good to go. Should have probably done this earlier, but because it's 6 p.m. But whatever. I'll try. So, 3 hours today. Hour and a half of new shit. Hour and a half of everything that I know. Today we're learning about narrowing conversions, which is when we're converting, at least the usual way is when we're converting floats to integers or to characters or something like that. So when one data type, by definition, when it is converted to another, you are losing data automatically. So a 4-byte float to a 4-byte int, you're still losing data because you're losing the decimal there. Okie dokus. Let's get it going. Potentially unsafe, because 3.0 to 3 isn't necessarily unsafe. We go to 3 to 3.0, that's fine. We're not worrying about anything. When we go to 3 from 3.0 and we're just killing the trailing 0 whenever we go to an integer, right, we get a narrowing conversion, but all we're losing is the trailing 0. Oh, and actually, oh, interesting. Excuse me. Oh, now we have a local repository. I don't know what I'm seeing here. I guess these are 2 commits? I don't know. At some point, I was 4 minutes through a tutorial to use Git in Visual Studio 22. The destination type may not be able to hold all values. Yeah, because if we do 3.4 and it can't hold 3.4, so it can't by definition. Even if floats can't go as positive or as negative as an integer of the same memory, the integer still can't hold all the values because there are other values in that range. So like between 1 and 2, there are all these different things, 1.0001, 1.0002, etc., all the way up to 2. Those are all values that an integer can't hold, and it's losing data. Which is why it's potentially unsafe, because we're losing accuracy here. So a floating point to an integral type, from a floating point to a narrower, lesser ranking floating point type. Okay, so like a double to a float, a long double to a float, a long double to a double. So like if we do double x, and then we initialize it with 3.4 LD? I don't know, what is the abbreviation for, so there's D, or is it, I don't know. So if we just do this, oops. Oh. Oh? What is that? It can't be a long because it doesn't make sense. This is cool because 3 is that, but 3.0 is not. Literal operator. Well, it's not the template. It's not the operator that's wrong. It's that, or I guess it's saying that there's not an operator that can operate on a floating point. Long double? I don't know what it is. Long double? There's long, there's double. No, there's F, there's floating point, which is fine. Because we're going up in memory, which in this case is a numeric promotion. But fuck. What is it? It's not D? It's not double? What is the suffix for it? What is the abbreviation? I don't know. Long double suffix C++. F? Oh, L? Wait, what? Oh, so 3.14 is always literal. There isn't a specific explicit one. Okay. There's F and there's L? Am I retarded? I thought I did L earlier. Oh, I guess not. I was just surprised that L was working because I figured it was going to be like 3L is a long, but 3.0L is a long double. Interesting. Okay. Oh yeah, so in this case, if we say bro. Okay. Really? It's okay for it to be... Oh, so I guess it only gives a narrowing conversion if it's sufficiently long? Oh, well that's truncation. That's not necessarily a narrowing conversion. Am I misunderstanding? To a narrower or lesser ranked floating point type. I'll have to read more. Unless it's constant expression and is in the range. And is in the range. So if it's constant expression, then it's okay. And if it's within range. So the number isn't too large or too small. It's within range, but maybe it's too precise. That's still okay. I feel like these things are not possible to remember. An integral to a floating point type. Wait, really? An integral to a floating point? Unless it's constant expression? Are you sure? Floating point to an integral? Integral to a floating point? What? Bro, apparently fucking not. Like, I'm not making it constant expression. So why is it... Oh, the point is because a float might not be able to hold all of what's in an integral, because an integral can go up to like whatever, some huge number, and a float maybe goes up less because it's holding precision in the rest of its memory. Because isn't it just truncation if the number is sufficiently large? Oh. Okay, so it can become a narrowing conversion at some point. And so the difference between truncation and a narrowing conversion, I'm not sure I know. Still not talking about truncation yet. Okay. Feels like maybe they're the same. You're going from something to something else, and the something else, the target, can't hold all the values of, or at least it can't hold the value that you're using. So I guess that's the point here. It's potentially unsafe. It may not be able to hold. So it's not necessarily narrowing unless the value is actually unable to be held. What is the point of this? To another integral type that cannot represent all the values of the original type. It seems like if it can't represent all the values, the end of story. Unless it's cost expression, and whose values can be stored exactly. I'm not sure how this part is relevant. It seems like the part before it is. From an integral type to another integral type that cannot represent all the values. Okay, we go from an int64 to an int32. Narrowing if the value is unable to be held. Okie dokie. It seems like my IDE is only flagging under this case. When the value can't be stored exactly. Seems like this is saying that it would be flagged more often. I don't know if this is an IDE intelligence thing or what. Okay. So what? We're saying this could be narrowing? Like, so with the undefined behavior in a reinterpretive, or maybe not a reinterpretive, of a, what is it, a lossy? Well, if we're going from signed, so if we're going from an unsigned int with a big S value that's too positive, so positive that a smaller integer can't hold, or even a same integer can't hold all the positive values, in the signed, it seems like it counts up from where it is through the negatives up to wherever it was. But in that case, it can't hold the value, so the behavior happens afterwards. So it's like there's a narrowing conversion then after. I'm not sure. Signed to unsigned or unsigned to signed. Signed to unsigned, we have a negative value, which can't be represented by an unsigned int. But then the unsigned int has modulo wraparound. So it seems like modulo wrapping is a response to the narrowing conversion. So is this flag due to a narrowing conversion then? If int x, or we'll just say unsigned int y, and it's -3, and then y. So this is a narrowing conversion. So the int and unsigned int, the reinterpretive conversions that we have to do a static cast to an unsigned int, like this. A static cast has a process that triggers. Oh, so the point is that, so what if we did, so this conversion is a signed unsigned mismatch. if we instead used brace initialization, then it's a narrowing conversion. So the copy assignment doesn't care about the narrowing conversion. It just says it's the type mismatch that's the issue. But the reason that the type mismatch is an issue is because of a narrowing conversion, where the value we have cannot be represented by the unsigned int. But if we do a static cast to an unsigned int, this itself is some sort of template function thing that returns an unsigned int and converts it. That way there's no implicit mismatch. So that function is how we explicitly say, hey, do the conversion and then use that value implicitly. We're cool. That's the point. Implicit narrowing conversions do it, because the compiler doesn't know that the user is saying continue. It is saying act with caution unless the user is already set in his mind. If you do a static cast, an explicit conversion, you're set in your mind and the compiler doesn't give a shit. But if you don't say that and you leave it implicit, the compiler is saying, hey, this guy might not know what he's doing, and flags it. Yeah, so this wouldn't have a mismatch if I didn't have it. Depends on how the compiler is configured. Meaning that I have warnings or treat warnings as errors enabled, so it does flag it. But otherwise, it wouldn't flag it in copy initialization. But it does for what's it called, direct list initialization. Yes, makes sense. Yeah, so maybe have checks to see, hey, is this value cool? Or like assert that the value is whatever. So like in the case where for some reason in a case where you're using an unsigned int to deal damage to an enemy, check before you apply the damage or assign value to the damage to be done. Because if you have some sort of value and then it gets subtracted because of damage resistance or something, and then it goes below 0, which means for an unsigned int it actually increases. Or rather, it goes below 0 and then you assign it to an unsigned int. Well, the unsigned int is then going to do modular wraparound because of this conversion, because it can't hold the value because there's a narrowing conversion here. Those are the same. The narrowing conversion is the description of the phenomenon that it cannot hold assigned value, so a negative value. Yes, so make them explicit. We got to do static cast stuff because we're saying, hey, compiler, we're cool, buddy. We're okay. So like if we had we'll do so we'll say So the player does 5 damage, and the enemy's damage resistance is 8. We would think, okay, we're not going to do any damage. Oh, well, fuck it, it's fine. In this case, I'm just going to do to an unsigned int. What? Hold on. Oh, it's the line 10. Oops, I don't need to do that. Okay, so we say, alright, the player is doing 5 damage, or in this case, we could just say player does 5 damage. Whatever, we'll just say enemy damage. Or enemy damage resistance 8. And then we'll say character damage. Oops. Player damage, character damage, enemy damage resistance. Okie dokie. Alright, so we're saying the characters we're passing the characters damage. So this is like an attack function or something like this. So there'd be like an attack that would say, or actually here, yeah it is. Let's just say avoid attack. Yeah. Okay, so we're doing a regular attack from player to enemy. Okay, we already have, this guy's already getting all the values from where they need to be. They're in their own spaces. We've included them from their own different header files, blah, 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 whatever. Okay, we're going to say player deals this much damage to enemy. Boom. Oh great, massive fucking damage. Why? Because we ended up getting a negative number when we calculated damage, and the unsigned int the damage to apply did not check to make sure that the damage was not overflowing. It needed to make sure it wasn't negative damage. Needs to check for negative damage. So, oops, we can include C assert. What happens if we do, it's not assert, yeah it is C, alright, well I hate that it disappears, but assert, yeah C assert, cool, and we can assert, we'll just say, unsigned int damage, boom, doke, so we'll get this and we will assert that damage isn't, well fuck. The problem here is this calculation, so we need something that's like a raw damage, and then we can return raw damage. So maybe we just say we calculate, so we'll calculate the damage. Int damage. Okay, so there's damage. And then we will assert that damage is greater than or equal to 0. And then we can return damage. Excuse me. Well, in this case, it's already known. Oh, well, actually, in this case, we should do static cast to an unsigned int damage. Oh, found. Oh, and actually, this is wrong. We need to assert this. And damage can't be negative. Really, we would just say, hey, if there's a check, then we just say, hey, if it's negative, then we just return 0 because there's no damage. But we're doing this just as a little check. Hey, let's see. Oh, what failed? Damage greater than or equal to 0 failed. So it is less than 0. Damage can't be negative. Okie doke. And what were we checking here? We were just checking narrowing conversions. Okay, yes, and making them explicit so that we know. Not always avoidable. They have mismatched types. Parameter, the function parameter, and the argument mismatched types. So we're calling it with a value that doesn't match the type. And then we'd have to go and change the type of the function, but maybe we can't. So we have to change the type, and we have to explicitly cast the type before doing it. Oh, and here's exactly that. We are converting the type and then doing it so that we do it explicitly. Therefore, there's no implicit conversion needed. Therefore, there's no type mismatch. Therefore, the compiler doesn't bitch. Yes, so remove implicit narrowing conversions, make them explicit. Yes. I know that it is intentional and suppress the warnings. Cool. Yes, so some function needs an integer. We have a double. We are calling it with a double. It's implicitly narrowing conversionly converting it. It's an implicit narrowing conversion. 5.0, we're dropping the decimal. We can't the integer can't hold 5.0, it can only hold 5. So if we were doing copy assignment, we'd be cool, but narrowing conversions are flagged, or at least detected, by brace initialization. So if we wanted to do this, we would have to do the static cast. So we could totally do static cast D, which we can right here, or just call it with this. But maybe this is the damage, and we say, hey, we got to cast the damage to be an int. It's a double right now, because there are different multipliers that have to happen properly to make the damage be accurate. And then we finally explicitly do the rounding error at the end. Instead of doing rounding errors in the beginning and then converting, and then you get even worse rounding errors. I'd rather my Minecraft sword get the sharpness multiplier, or the additional sharpness added to it, and then at the very end we round it. That way, if all those little additions of less than 1, so like 0.75 or whatever, add up to something greater than 1, I get that. Instead of it being killed and we don't get the 0.75 because we cast each one. I'd rather cast at the very end. So add all the shit up literally, and at the end cast it, and that's the one rounding error. Yes, we know this. Brace initialization disallows narrowing conversions. Yes. Which is why we use this, because it then detects it. Cool. Attempting to do so produces a compile error. Yes, we're very, very familiar with this. Yes. So it could be double to int, it could be signed to unsigned, it could be unsigned to signed. Could be both ways, right? I don't know if I've gotten sloppier with my typing or what. I'm making more errors. I don't know. Maybe I'm just going faster. It feels like maybe that's it. In X, and we're saying, hey, 3.0, okie doke, and then X, right? And I'm curious, is it going to say that first? It will. Cool. So I was adding X because I thought it was going to say, oh, variable X isn't used. And now we could say float Y and give it 3. Oh, well, it's not detecting that as a narrowing conversion, but if we do this, oh, now it's a narrowing conversion. What about that? Oh, now it's into float narrowing conversion. Yes, because this value cannot be held within the float. But if we reduce it a little bit more, oh, still, how small are floats? Oh my god. Floats only go up to like 35 mil. I mean, maybe it's more than that, but it's probably more than that. It's likely it is more than that. Yeah, so we have to do the static cast that way that there's no narrowing conversion that is implicit. Implicit narrowing conversions are detected here. It's not that narrowing conversions are disallowed. It's that narrowing conversions are disallowed in the initialization process. So when we are saying that the result of this expression is one type, and the target type of our object is another type, and the target type can't hold all values of this, that's the narrowing conversion. But if we instead do the conversion already, and the result of this matches the type, then there's no narrowing conversion. So we do the conversion before, where we're taking an int and getting out, or we're having a double coming in as a parameter, or at least in this case as an argument, but also copied to be the parameter of, I guess, the static cast function. I don't know, template thing, something like that. I'm not sure what those are. Like a uniform int distribution. It's like it has a function, but it also has some template shit as like another parameter or something. So it's like it expects this guy, but it also expects arguments. Okie dokie. Yes, so we do that before the actual initialization process. We want to resolve it in the static cast explicitly, and then we initialize. Some const expression conversions aren't considered narrowing. The source value of a narrowing conversion isn't known until runtime. The result can't be determined. Meaning that we don't know what the type, or just we're talking about just the value. So like if we're saying, if we initialize that double with 40 or whatever it is with 35 million, it's cool. But if the user instead inputted 350 million, then it would be a narrowing conversion. So yes, sometimes it isn't known until runtime. Makes sense. And whether the narrowing what the result isn't known until then. We don't know if it's going to be correct or not, because it's narrowing regardless. By definition, it is apparently narrowing, or sorry, right here, it's narrowing, but we don't know if it's actually the optional, the may be unsafe part. We don't know if it's actually unsafe until we know the value, which is why some aren't considered narrowing. Maybe, I think that's what this is saying. For example, okie doke. So what do we have? We are telling the user to input an int. We have an int. We are extracting the value to the int. Okie dokie. We are printing. The print takes an unsigned value. So if we do -5, it's going to print a big ass value. If they do 5, it's just going to do 5. Which means we don't know whether this is going to be a narrowing conversion or not. Because it could be 5 to 5. The value is an int. The value they put in is stored as an int. But it's okay. Maybe, well, yeah, if it's at runtime, then the compiler won't. Well, but maybe the compiler will complain first because it sees, hey, you're extracting something here as an int. Yeah, I'm actually curious what even happens in that case. So if we say that there's a print function and it takes an unsigned int user value, and then it just outputs the user value, and then we call or we say, and we just say okie doke, and then we'll just say get user int, int get user int, enter an int, and then we'll say int user int, standard character input. Technically we should check to make sure, hey, we're removing the excess input. If there's anything extraneous, we're checking to make sure that it didn't fail. And what else? Don't care if it's meaningful or not. I mean, we could also do that too, because then maybe they enter A and then it's a failed extraction and then fucking blah blah blah, but whatever, it's fine in this case. Okay. Standard character input. I've learned how to do debugging, or data validation, input validation. user int, return user int. Okie doke, are you cool with it? Cool. It automatically sees it. Yeah, that's what I was thinking, because it was gonna say, hey, we're having an int, we're converting. This guy, this int isn't, this argument is an int. This parameter is an unsigned int. We're having an issue here. But if we do a static cast to an unsigned int, now we're cool because we've resolved this to be an unsigned int, and now there's no implicit conversion. In this case, we're saying 5 and it does 5, but if we do negative 5, it does craziness. If we do negative 1, it does this. Okie doke. Yo. Okay. The compiler doesn't know when it is called. The conversion from that will be performed at that time, and they may be value preserving or not. So a compiler that has the warnings enabled will say a warning. Was it a warning? It was a warning. Meaning that it doesn't know. It could be a warning, which means it gives a warning because it could be. It's not going to be like, oh, it's possible for the value to match and not be unsafe narrowing. It's okay, 5 to 5, an unsigned int holds 5, an int holds 5, cool. It's going to say, hey, it could be that the value is not 5, that it could be negative, and an unsigned int can't hold that. Therefore, there's your warning. Excuse me. But for some constant expression ones, we're not. Unless it is constant expression. It is narrowing from an integral type to another that can't represent it unless the value being converted is already const expression and can be stored, meaning that it's not narrowing if it is safe and const expression. But it seems like it's also still not narrowing, or maybe it's actually a different process, but it seems like it's also not flagging anything if it isn't const expression and the value just can fit. It seems like as long as the value can fit, we're cool. But maybe it's the case that there's something different for const expression. So when the source value is const expression, it must be known to the compiler, duh. In this case, the compiler can do it in check. It is not narrowing. Okay. Meaning that these signed unsigned mismatches are potentially narrowing. They aren't necessarily narrowing because it's the value that determines whether it's narrowing. If it's preserved, then it can say, hey, something is being assigned, or a const expression is becoming, or well, entire conversion. Because if we're initializing something with a const expression value, well, we don't know if that value is const expression, but if we're initializing a const expression with a const expression, or we're just initializing a const expression, then yes, it checks and sees. So what happens here if we say const expression int, unsigned int y, and it gets, well, what's a case? Yeah, so if we say 40, oh, actually, here's the question. If we have a const expression in x, and it is 5, and we assign this to be x, type mismatch, ooh. But it's const expression, so it's okay. If this guy wasn't const expression, 1, it's going to say not constant, must have value to a constant, but if we just left it unsigned, then we get the narrowing. And it's because it isn't, It's known at compile time, but it isn't. Well, what if it was const? Seems like it's also working for const values, not necessarily const expression, but maybe that's just because the IDE's compiler is being smart in doing that conversion, so we don't actually have to go all the way of making it const expression. So if we're initializing it as a literal, well, it seems like it's the const part that is actually holding water. It's saying, hey, this guy, the value's cool. And he's always gonna be cool because he can't be changed. He's const. Yes, the value must be known. The compiler will do the extra. So basically, the compiler will do extra checks and will fully evaluate the thing to see if it's narrowing or not. Instead of if it's not, I don't know which way though. I think I'm trying to see if exactly how it's going. Well, yeah, if they're both constant, then it knows that their values are unchanging, which means that they can be initialized as each other without any issue because it already checked the values and the values are not narrowing. The values never will be narrowing. So the conversions are okay. For example, if we have a const expression int this guy, and oh, but I also didn't check that part. This int x is 5, or unsigned int y is x, we're cool. It's just not referenced. But if this guy was -5, then the compiler will say, hey, it's value specific. That value is not good. It is a narrowing conversion. Because an unsigned int cannot hold a negative value. Okay, it's just explaining what's going on here. Yep, from an integral type to another integral type that cannot represent all the values, meaning an int can be negative, an unsigned int cannot be negative, therefore an unsigned int cannot represent all the values from an int. In the case where it can represent the current value because it's constant, and the compiler will look at the constant and say, hey, are we cool? If we're cool, we're cool. But if it's not cool, and it seems like it doesn't care about the target, it only cares about the value. No good because of negative. Good because it's not negative, yes. So it's checking, hey, here's the value that is being converted. Is it cool? That's what happens at compile time, or if it's constant. The compiler will do some extra lifting. Ideally, if it's const expression, so it's 100% known at compile time and unchangeable, and all the compiler is doing every optimization possible and literally substituting int x for that value, so that anywhere it's actually used as x, it's removing x and replacing that with just the literal number. Boom. That way, future parts don't have to go and reference wherever the fuck the number is stored. Instead, they just say the number. That's it. Expressions are quicker, more evaluated faster, more efficient. So, if this guy is const expression, or we'll just say constant, at least in this case, but at least in the by definition const expression, it will check, are we cool? And if we're cool, we're cool. If we're not cool, we're not cool. If it's not constant expression, it will assume that we're not cool, because we could be not cool. There could be a world where this guy becomes -5 and this guy is assigned him. No, sir. No good. Seems like the constant part is the important bit. Because the value is known at compile time, so it feels like it's not that const expression values are known at compile time. It feels like it's the constant part, because it works for constant. In the case of N1 and U1, N1 is an integer, U1 is an unsigned, so the conversion cannot represent all yes. However, its constant expression, the value is cool, therefore it's not narrowing, and we're allowed for N2 and U2. -5 can't be represented. Can't be represented, so it is narrowing. Cannot. Compiler will halt. Boom. Strangely, from a floating point to an integer type that do not have a constant expression, or wait, hold on. Do not conversions from a meaning that it is always narrowing. It won't check the decimal. You bitch ass. Maybe because it's hard to evaluate the floats. Maybe there's some sort of rounding error. It's like if the two literals are equal to each other, it might give you a false when it's actually true, like 0.1 is 0.1. Or 0.1 plus 0.1 for this value, 0.1 for plus 0.1 for this one, and then or for those two separate objects, and then we do equivalency, we check to see if they're equivalent, and then it fails. Maybe in this case the compiler can't tell you for certain if this guy is actually 5.0. Therefore it says, hey, any floats to ints? No, sir. Even more strangely, from a constant expression, floating point down to a narrow are not narrowing, even when there's loss of precision. So in this case, it's a loss of precision, but it's a fully lost value. So like 5.9, or like 5.92 to 5.9 is a loss of precision, but 5.9 to 5 is a full-on, like, whole data type difference. Conversions from a constant expression floating point type to a narrower one is not narrowing even when there's a loss of precision. And it seems like it's because it can represent it, just not to the same amount of significant digits. Okay, so just be careful when you're converting from doubles to floats and long doubles to doubles and long doubles to floats. It's not narrowing, so list initialization will not pick, or direct list initialization will not pick it up. So if we say, oh yeah, I mean, we tried that earlier. We tried a long to a float or a long to a double. Wait, when it's constant expression. So if we have float x and we initialize it to be 3.4, it's truncation. Same thing here, long double issue. If we say constant expression, well, that's still the error, so it needs to be, what if we do, okay, yeah, I didn't think I could define this guy in here. But what if we just say, I could just do that. Long double to be 5.23. Okay, we're cool. Oh, well, it doesn't have a name. X. And then we'll say float y is x. We're still getting the error here. So the point is we're saying this not narrowing. Yo? Okay, so I don't know what the truncation part is, but I guess it's not flagging for the same narrowing thing though. List initialization with constant expression initializers. They're useful when list initializing non-int, non-double objects. What are you talking about? There's a fucking gnat. Within 5 years, I'm getting LASIK. These glasses are so fucking annoying. Next year, I'm gonna go, when I've got the big bucks next year, I'm going to see an ophthalmologist and getting LASIK. That's just how it is. I can't. Shit's so annoying. All the years of gaming adding up. all at once too. List initialization with const expression initializers. It's cool because it won't flag if the guy's const expression. If it can fit. When initializing non-integer, non-double objects. What the fuck are you talking about? Oh. Oh, so that's what's going on whenever we're doing... So what happens if we... If I just have int x and it's 3, and then we just have float y is x, and then say y. Oh! That's where the narrowing conversion comes in. But if instead there is no x, and it's just this value is const expression, so the compiler is saying, yo, the motherfucker is cool. He's good, bro. We gotta run him by the doorman. But if he's not but if the value isn't const expression, then the doorman doesn't see it. You're slipping by. Gotcha. That makes sense why that's working. And that makes sense why when we do L there earlier, it was okay. When we were saying... We're taking this guy. This is a double that's const expression, so it's cool. This is a long double that's const expression, so he's cool. This is a long double that's const expression, so he's cool. This is capital D doesn't exist. Okay, noted. Oh wait, yeah, because there's no such thing as D. That's why. There's no double. There's no double. It's long, long, double, double, float. All of those are literals. Literals are const expression because they're known at compile time. Therefore, they are ran past the doorman, so we're cool. So we can use const expression objects or int or double literals to initialize the guys, even when there's narrowing conversion. This allows us to avoid having to use literal suffixes. Meaning that they're cool. We don't have to specialize this or say the type, having to clutter it with static cast. Meaning, like, if we were going to do 5 and then have to convert it automatically, we have to say static cast to a float 5. Instead, we could just do 5 and it's const expression and we're cool. So in this case, oh yeah, and 5 is an int right there, but it's a const expression int. So the doorman, the compiler, will say, hey, 5 is cool, Mr. Unsigned int. He's good. Boom. Hey, double 1.5 is cool, Mr. Float. He can fit. We don't have to do static cast to an unsigned int, literal 5. We don't have to do 5u to say that it already is the literal. Same thing here. Or const expression n is a const expression 5 integer, which means the compiler says, hey, he can fit within you, double D. You're good. Double D, holy. And then the literal 5, hey, he's okay. He can fit within a short. We don't need to do static cast to a short. And this also works with copy and direct initialization. Okie doke. Well, yeah, it seems like if anything, those guys don't even give a shit. Initializing a narrower or lesser ranked floating point with a const expression value is allowed as long as it's within range, even if it doesn't have the precision. Yes, meaning that the list initialization won't flag. As long as it's not too big or too small. Yes. Okay, doke. Floating point types. Well, yes. Float double, long double. Duh. Something like this is legal. So this is too much precision right here. This is a double. Floats only go to like 6 total numbers, something like that. 6 significant digis. 6 or 7 maybe, I think. Or maybe it's 4 or 5, I don't remember. But something like this. This is a double for show. Precision is being lost because this is going to go to like 1.23456 or something like that. Or maybe it'll round to 23457. Error. Oh, compiler may issue a warning still, but it's legal. So it's not an error. Could be a warning though. No good. Be careful. Be careful when you're initializing narrower, in terms of memory, floating points with wider floating points. Be careful. Yo, can I use it? What the fuck happened? I clicked something. I don't know what it was doing. Okay. Arithmetic conversions. Arithmetic conversions? What the fuck are you talking about? Yes, expressions are evaluated according to precedence and associativity. So yes, addition before subtraction, or multiplication before division, or multiplication before addition or subtraction, or assignment after all of those regular ass PEMDAS guys. Logical and before logical or. So it's or is first. No, and is first. So it'll be like this and this, or this. So no parentheses. It's this and this, true or false. And then the result of that, or this. It's not this or this and this. And is first. And then associativity is the reading order. So 5 plus 3, or 5 plus x assigned 3. So it's not something is assigned 5 plus x and then assigned whatever. No. It is 3 is assigned to x. Now x is 3. Doesn't matter what it was. And now x plus 5. And then that gets assigned to whatever the fuck. Or that's the result. So now it's x plus 5. So now the result is 8. No matter what. So we're saying 3 plus 2, because I think most things are right to left. And then it is initialized to x. So the binary operator plus, meaning 2 operands. 2 operands, both of type int, they're literal ints. Both operands of the same type. That type will be used to perform the calculation, and the value returned will be of the same type. Oh, so the question is, in arithmetic conversions, so when we're talking about operations, and the operands are of different types. 2.5 plus 5. Oh, we talked about this before. When we have operations with an unsigned int, it's like it goes to the more narrower one. So like 2.3 plus 5 is 7.3. Why? Because the result type is the, I don't know, like the more precise, or the it seems like the weirder one. Like the one with more I don't know. Because if we do 2u plus 5, we get 7 as an unsigned int. It is unsigned addition. It converts the integer to an unsigned integer and then adds them. If we do 2.3 divided by 4, we're doing float division. So it'll say 5.0. So 5 is an int converted to a float, or to a double. Then that, or whatever the first one is divided by that. 2.3 divided by 5.0. It's not, 2 divided by 5, 0 or something. It's going to be like 0.4 or 2, whatever the fuck. So what happens when the operands of a binary operator are of different types? Something, what? What is this? Oh, the question is, what type is y here? In this case, it's given y as, or it's given 2 int 3.5 double. Is the result an int or a double or something else? Seems like there are probably rules, maybe. If a this and a that, then it's a that. If a this and a that, and it's a that. If it's a this and a that, it's a that. Certain operators require that their operands are of the same type. If one of these is invoked ones of different types, what, compiler error maybe? Or one or both will be implicitly converted to matching types using a set of rules called the usual arithmetic conversions. Meaning, in this case, it seems like if you have an int and an unsigned int, convert the int to an unsigned int. Why? Because the unsigned int is probably the one who's going to be bitching, I think. Because it's probably more common that you give a negative value and it fucks up an unsigned int compared to you giving an int a too large unsigned int. Feels like that's probably how it is. Because half of the memory of an int will give you narrowing conversions and tight mismatches and shit for an unsigned int. But only the but half the answers for an unsigned int will do the same, because half the memory of an unsigned int is larger than the maximum of an int, just like half the memory of an int is lower than the minimum of an unsigned int. The matching type produced as a result of the usual is called the common type. Gotcha. So you'll get like a float and an int, and it'll convert the int to the float, and the float is the common type. So there's like a least common denominator kind of thing, where they say, hey, which one of these is the bitch ass? Like, there's two kids, who has to share? Well, it's the older kid who's got to share. In this case, the int is a cool guy, the float is a weirdo, so int, you got to play on the float guy's level. You got to become a float now, buddy. GG. Int, you're cool. Unsigned int is a bitch ass who's weird. Int, just play on his level for a little while. Int, you are now an unsigned int. Boom. We have an unsigned int as the common type. The operators that require... Okay, so every fucking operator. That's what's happening here. Operators that require operands of the same type. So there are relational operators. Ooh, some bitwise shit. Binary arithmetic. Arithmetic. Yes, so if we say 2 less than 2.3, it's going to convert 2 to 2.0. That way you can evaluate the shit. Gotcha. So our standard relational guys, binary bitwise guys, I don't even really remember them, honestly. This or this, where we're passing, are they the same or not? So it's this and this, they're the same. Are they the same? Or this? And the ternary operator, ooh. Well, the conditional has 3 types, bro. Ternary. So, or wait, which are we saying? We're saying, oh, well, duh. So, well, the condition's on the left, and then the 2 values. So really, we're talking about the binary part of the conditional operator. We're talking about that little colon right there. We're talking about value to the left, value to the right. Hey, if this is true, then you get this int, or if false, you get this int. Ooh, that one's a float. Well, actually, this guy is now a float, and this guy's already a float. Overloaded operators, no fucking clue, are not subject to the usual conversion rules. So if it's overloaded, then what? It'll stop behaving like that, maybe? I don't know how that works. No clue. The usual rules. Highest rank. Oh, they're in rank. Excuse me. Well, it seems like it's maximizing the chance that the operation will yield an expected value. So instead of converting a long double to a double, and then you lose data, and then you get a way smaller answer than you thought, because you added this big ass number in this smaller number, and the big ass number was in a long double, and the smaller number was in a double. If you added the two, you would lose a lot of size of the long double, and then you get a way smaller value. So instead it converts the double to the long double so you don't lose anything, and then you have two long doubles as the common type. Okie doker. Int long float double long double. KO. Dang, I wish it was called a double double. These are the rules to find a matching type. Only 2 rules? Easy peasy. If one is an integral type and one is a floating type, the integral is converted to the floating. Otherwise, any integral operands are numerically promoted. Okay, makes sense. And then same thing probably here. Oh, and then after promotion, if one is signed and unsigned, special rules apply. Which are, well, we haven't seen them yet. If they're not, the operand with the lower rank is converted to the type of the high rank. Motherfucker, that already happened. It already happened. Otherwise, it's numerically promoted. This should just say, hey, integral type becomes, these guys become this type. And, or well, it should be same type, promote the lower guy. Ints become floats, signed becomes unsigned. Boom. Yes. The special matching rules. If the rank of the unsigned is greater than... Oh, wait, really? Maybe that's how it is. If the rank of the unsigned is greater than or equal to the rank of the signed is converted. In all cases I've done it so far, it's always been ints and unsigned ints, which means they're equal to, which means the rank is equal, so the signed is converted to the unsigned. If the type of the signed can represent all values of the unsigned, hold on. If the type of the signed can represent all values of the unsigned, the type of the unsigned is... Well, fucking duh. Oh my god, dude, you could have just left this to be one bullet, bro. This is the same. This is already implied here. If the rank of the unsigned is greater than or equal to, the signed becomes unsigned. Therefore, if the signed is greater than the unsigned, which it must be in order for the unsigned to fit within it, because the unsigned has twice the memory positive, so the int, which has half the memory positive, half negative, must be big enough to fit the whole unsigned, and if the whole unsigned can fit, then the unsigned gets promoted to the signed guy. So if we had an int 64 and an unsigned int, which is basically an unsigned a uint 32t, then the unsigned int 32 would be promoted to an int 64. Because an int 64 can hold all the values of an unsigned int and more. It can also hold the signed negative shit. But if the unsigned is not a greater or equal to rank, and the signed cannot hold the value, so if there's like an intermediate, like a 6 byte, a 48 byte guy, because we need a 64-bit int to hold all the positive 32-bit unsigned. So if we had somehow a 48-bit int, so what is that, a 12? A fucking 12 byte? Or yeah, a 12 byte int. But I guess we say 32, 64. So a 48, if there was a uint, if there was an int 48 that cannot hold all positive numbers, all possible values in a uint 32, it must be double to hold it, then the int still gets converted to the unsigned int, actually. Otherwise, they're both converted to the corresponding type of the corresponding unsigned type of the signed operand. So, a uint48, maybe? But in that case, it's not greater than or equal to, or it can't fit. Otherwise, they're both converted to a uint48, it seems like, but that doesn't exist. Okie doker. Oof. Oof. The type ID operator. What, that reports the type? Ooh, .name. Does it return a string? So we have int I. Oh, and we are, okay. We're saying, hey, it's probably going to say int. And then double 3.5. And we're outputting the type ID of D. And we're doing the .name member function of that object class. Something like that. Ooh, that's interesting. Type ID has a parameter, and then it has a member function that operates on the parameter that it gets. Have I even seen anything like that? It's like type ID, or I guess we're calling the function on the function. I don't know. No, I guess not. We're saying it's an object of something. I don't know. I'm surprised it's not just like type ID.name or something, or type ID parentheses.name, but the parentheses, I don't know what the parentheses is for. I'm just surprised it's not like .name, whatever, type ID name. Or just, yeah, I don't know. Okay. And then in this case, we're saying I plus D, and then we're giving the type of the result, which in this case, we have an int and a double, and we know that ints are always converted to their floating point counterparts. Right? Yes. So there's no integral promotion because it's just converted to the same type of the float. In this case, yes, the double has higher priority. Well, it doesn't matter about the higher priority. We're just saying that, hey, floats take priority, period. Or floating point values take priority always. So 2 becomes 2.0, 5.5. Yes. And it says double 5.5. Int double 5.5. Yes. Implementation specific. Oh yeah, because maybe an 8-bit int is a regular, or an 8-byte int is an int still. But on some implementations, it would say a long. Now, if we add 2 values of type short, we say a short and a short. Oh. Oh. Okay. So if we're adding them and getting the result, and we're not assigning that to be to a short. Oh. Well, yeah, because the result is some sort of little object. So what happens when we add a short and a short? We don't actually even have a fucking short, so they go promotion to int. Which then means we have a narrowing conversion when we assign that to a short. So if we had a short and we assign him the result of short A plus short B, he's doing the narrowing conversion of the int that was yielded after the integral promotion of the short addition. Jesus. So it's going to say an int. Oh, well, actually, I guess they both get promoted to an int first. What is this? What's happening here? Okay. Getting Tarkov so I can deal with some cravings I'm having. I'm just going to say, fuck all the quests. I'm just going to go and fight, I think. And then buy shit. I'd rather have better quests. I don't like Tarkov's quests because they don't make sense. I don't want you to ping anything. I just want you to say, hey, this is the building, or look around and find this, and here's what I know. And then you can find legitimate clues and evidence in the game. But in Tarkov, it's just people fucking guessing around and stuff. It's like just some mistranslation. Maybe it says it in Russian, but let's just find like therapist quest Tarkov real fast. And then we'll find like, let's just find list of quests. All right, here we go. Search mission. They reported USACs, investigate it. The convoy had this stuff. Find my convoy in the camp. Oh. Okay, this is actually an okay quest. Alright, here we go. Everyone knows this quest. You're just finding a pocket watch. Okay, cool. And it's in a room. Okie doke. Alright, well, we gotta get a key to open up a thing and then get it. Okay, cool. That's the tanker driver. His family left. He lived in a three-story room. He had a chain. Find the watch and bring it to me. Oh, wait. Wait, these quests are actually becoming okay. Find a safe route for them. Oh. Maybe I'm just retarded, so I never... Either they were rewritten, or I'm just retarded and I always misread them, and they were always gibberish to me. I'm like, dude, how does anybody know what this guy actually wants? And you have to fucking Google it. Actually, I think some of them were self-explanatory, because you didn't have to Google all of them. You only had to Google a few, like, where the fucking trucks are and stuff. I guess I just got spoiled by existing resources. Int is the lowest rank. Signed and unsigned. Okay, so we have unsigned int minus 10. Well, 5 minus 10. Well, in this case, it's just gonna, isn't it just gonna be 5 less than, yeah, exactly. So it's gonna say 5 unsigned. That's an unsigned int. 10 is an int, which means that the unsigned int's data type is of the same rank as the signed int's data type, which means that the signed is converted to an equal unsigned type. So now we have an unsigned 5 and unsigned 10, which means 5 minus 10. Excuse me. An int would be negative 5, but an unsigned int would be 5 less than whatever the maximum value, or well, 4 less of whatever the maximum value of an unsigned int is, which is 4.3 billion. And 5, something like that. So minus 4 means this. Makes sense. Negative 5, but we get this. Well, duh. The int is converted to an unsigned int, and because negative 5 is out of range, we get the result we don't expect. Well, I mean, we do expect it here. Counterintuitive result. Well, let's see what happens here. They're saying bool alpha, which is just saying, hey, output the true false, not the 0 or 1. We have negative 3. Well, we're saying this is greater than this. Okay, here we go. So we're saying negative 3 and then, oh. This is going to say false, and the reason why is because 5 is unsigned, and then we have negative 3, which is an int. And again, same shit as previous, where the int is an unsigned int, and then, or the unsigned int is equal to the same, or to, it is an equal int priority of the signed int. They're both of the int level. Neither is an unsigned long, or a long, or a regular long, or a regular long. It's a regular unsigned int and a regular int. Therefore, the int is converted to an unsigned int, which means this negative 3 is actually 3 less than, or 2 less than whatever the maximum value of an unsigned int is. So 4.3 billion and 3 in this case, because it's 2 less. And that is not less than 5. So this is false. Yes, negative 3 is converted to the large ass unsigned int that is much bigger than 5. Therefore, it prints false instead of true. Avoid unsigned ints, yes, because you're mixing them and blah, blah, blah. I don't know why the fuck you would say 5u. I have no idea why you would want to do that. I mean, if we're talking bitwise shit, and we're trying to min-max memory, then maybe you do that because if you said, I don't know. Nah, I don't think you'd want to. I was thinking for a sec you might want to say it to explicitly say, hey, this is an unsigned. Oh, actually, you would. Because if we're talking about a super tiny integer, maybe the integer can only go up to 127. So if you say 128, that is too big. But if you say 128u, then it's actually okay. Because the regular u, a uint 8, can go up to 255. Whereas an int 8 can only go up to 127. So it actually does make sense that you would use u like that for the tiny little manipulation shit where you can't get another fucking byte. You only got one, buddy. Yes. Okie dokie. Common type and common type T. Oh yeah. Let's get is it type info? Let's update. Include type info. Include IO stream. Need standard character output. Need standard type info. Dot name. To get name of data or of get data type name of X. Main in X standard type info of wait what? Oh, standard type info X dot name. Oh, what happened? Hmm? What? What you talking about? Yo, what is happening here? Ah, oh, motherfucker, it's not type info. What the fuck? It's type ID. Nobody knows what a damn type info is. Oh. Oh. Ooh, an N64. Ain't no such thing as a long. Damn. Counter cases where it's useful to know. What am I tasting? Oh, the pasta I made earlier. What is the point of this? Oh, just to get the common type. Interesting. Type traits? Oh, hell no. Well, we could use it just to what? Find out? No, it's in double, yo. An unsigned int in a long. Well, an unsigned int is a 32-bit unsigned int, whereas a long is, I think, a 64. Well, maybe a 64. So maybe it's actually only a chance, but I
think the unsigned int would become a long if the long is a 64-bit guy. Because if we're talking about doubling, it's 4 bytes, 8 bytes, 16 bytes. Oh, wait. Yeah, 16 bytes would be 128 bits. So, oh wait, no, 16. Oh wait, yeah. An 8 byte is the big one. Okay. All right, so we could get common types if we wanted to figure out those, so we could just print them out. Was it type traits? Oh, I gotta update that in a minute. Include type traits. Okay. Wait, common type int double. Uh-oh, what are the issues here? Type name is not allowed. Int x, int y, x, y. Bump, bump, bump. No, sir. No luck. What? That's type T. Common type int type T. What's the point of the type T? Or the type, if type T is the important guy? Hello? Common type T. And now long double? What? What you talking about? Double and long? Hello? Oh, it's the type shit. It's not a fucking parameter. It's a fucking template thing. Long double. Weird. Whoa. What is that? Expecting an expression instead of a type? Hello? So what if I just did that? Is this some sort of thing that's wrong like that? An expression? Hello? What are you talking about? This whole thing is surrounded. What about? Huh? Standard common type T. I don't know what I'm supposed to do with it. It returns the common type? Are you sure? So what happens if I just do that and that's all? And we call it a day. Oh my god, I guess we're done. Oh my god, that scared the Okay, 30-minute break, and then I'll teach myself some more shit. Time to update Tarkov so I can maybe try single player, because maybe it's fun. I don't know, I'm getting a craving.